और यार इंडिया में
Hello, Piyush. Audible? Hello, Piyush. Am I audible?
Yes, sir, you are audible, sir.
Yes, sir. You are audible. Your voice is clear.
Yeah, all yes. Thank you for confirming. So, very good morning, you all. I welcome you all on this fifth day of this FDP here. Our expert, Piyush, from the bioprinting industry has already joined us, and we are waiting for more participants to join. And in a couple of minutes, we will start.
ಟ್ವೆಂಟಿಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆದ
Hello, Piyush. Am I audible to you? Because you have joined, but you're not audible, I think. Piyush, can you confirm? Yes, Piyush. Audible now?
Yeah, audible now, sir. I think
Yeah, I think earlier
is the
some.
same previous last time.
Yeah. So I think it is 9:58. So what we can do, we can wait for few 1 or 2 minutes so that other participant can also join.
Sure, sir. No problem.
Yeah. Then I will request you to deliver. Yeah, please.
Yeah,
Yeah. Just waiting for a few more minutes, then we will start.
sure. No problem, sir.
Yeah, so dear participants, welcome you all again here. So we are having our expert, Mr. Piyush. So he's also actually because of some unavoidable reasons, actually because of the some another assignment of Mr. Piyush. So we have shifted his session to in the morning. So welcome, Mr. Piyush, to this session.
Thank you so much.
Yeah, so we are just we have now sufficient number of participants on this platform. So okay, so I think there is no need to just introduce you again because you have already taken our previous session and it was very insightful and our participants were very greatly interacted with you and lots of queries were discussed that time. So I think you will just go ahead with that. Okay, so now just request you to just deliver. Session is yours, please.
Yeah, thank you so much, sir. So I'll quickly share the screen to let me know if you can, if the screen is visible. Yeah. So is it visible, sir?
Yeah, please. It is very clearly visible. Yeah, before
You can.
starting, please, I request you all, please don't unmute in between. It really affect the performance and delivery of our session expert. I humbly request you all, please take care of that. Don't unmute in between. Okay. Piyush, I think
Uh,
over the slide, you can also hide that portion. One strip is coming, na? You are sharing or something. So you can also make it hide if
okay,
possible there so that it will be, yeah. Yeah, it is, yeah.
okay,
Good.
sir.
Yeah, please go ahead.
Thank you.
Thank you.
Sure. Thank you so much, sir, for the for inviting me for the lecture. So, in the last session, we discussed about the practical application of 3D printing in the medical sector. So, in today's session, I'll talk about the practicality of 3D printing, like what are the design constraints, what we should be consider while design for 3D printing, and what are the different kinds of failures what we expect while doing the 3D printing. So practically whatever the problem, whatever the things that we are going to face, so I'm going to give you the glimpse about all that, so that when you do a 3D printing you should know how to design for 3D printing, what should be the criteria, what you should be taking, what you should be looking for while making a design for 3D printing. And even if while doing the, once you make a proper kind of design, so when you do the 3D printing and you see a kind of a failure in the 3D printed part, so for which particular reason that failure have occurred. So I'll just walk you through the journey of the entire process of the practicality of 3D printing. So that will be the today's outline for the session. So let's begin with the session. So yeah. If we talk about exactly what is 3D printing, it's a process in which we convert any digital file into a physical file by adding the material layer by layer. So it is being known as a 3D printing, and there are majorly three types of 3D printer which are available in India, which are available. So there are plenty of other techniques as well, like binder jetting is there. Then we have a metal 3D printer, SLA, metal 3D printer, LOM is there. But apart from all those techniques, the three major techniques which are mostly and widely been used in the sector are FDM, SLA, and SLS. And among these three techniques, we will be focused our talk only on the FDM 3D printing process technique. Okay. So what exactly is FDM 3D printing technique and how FDM 3D printer looks like? So let's talk about the anatomy of the 3D printer. So in the figure, we can see this is an open DIY type FDM 3D printer. So each 3D printer have mechanical component and electrical components. If we talk about the mechanical component, and we have the body frame, then we have the smooth rods. So on the smooth rod, the positioning mechanism or the extruder will move, like the nozzle will move in X and Y direction, the bed will move in Z direction. Like we have a different configuration. The image which shows has bed movement in Y direction and nozzle movement in X and Z direction. So on the smooth rod are also known as a guide rod. So on which the component will move or glide. Then we have linear bearings. So the bearings, we provide the bearing for the smoother movement of the assembly on the smooth rod or the guide rods. Then we have lead screws and nuts. So lead screws positioning provides the positioning mechanism for the entire mechanism, either to move up and down in the Y direction or in the X direction. So this is why the lead screws are there. Then we have timing belts, timing pulleys are also there. So this timing belt and timing pulley are also responsible for the movement of the nozzle or for the bed. As here we can see the black portion on the center of the bed is nothing but timing belt, which will move the bed in Y direction. Okay. Then we have coupler, flexible coupling, so and various other mechanical components. So I have only listed down few of the main components which are there in the 3D printer. Then if we talk about the electronic component, then we have the extruder motor and extruder assembly, so which is responsible for extruding the the material out of the nozzle, and it also houses the heating mechanism of the entire 3D printer. Then we have the X, Y, Z motor, which are responsible for providing the motion in X, Y, and Z direction. Then we have the main board, which is the motherboard of the printer. Display is there, power supply is there, heaters are there, thermostat is there for the bed and extruder, which actually records the real time temperature, which records the real time temperature so that we can maintain the temperature within the 3D printer system. Then we have heated bed, extruder fan, and turbo fan. Extruder fan is been used to cool the extruder assembly so that the extruder assembly should not get overheated. Then we have turbo fan, which cools the material which has been extruded from the nozzle. So we should know the difference between the extruder fan and the turbo fan. Basically, extruder fan is used to cool the assembly, and turbo fan is used to cool the material which has been extruded from the machine. So this is the difference between these two fans. So while assigning the values of the extruder fan and the turbo fan within the slicing software, we should always know the difference between these two things. What is happening now when if the difference has not been clear? So many times we put the value what needs to be there in the extruder fan. We put the optimized value of the extruder fan in the turbo fan settings, and we put the setting of the turbo fan into the extruder fan setting. That is mostly and the most common issue which has been there while making the settings for the 3D printers. Then we have two kind of configuration for the FDM. One is the core XY and another one is the delta configuration. So these two configuration are currently being used for the FDM kind of systems. Okay. So now this was all about the FDM kind of 3D printer, how exactly it looks like and what are the anatomy of the 3D printer. Now let's move towards the design constraints. So what are the design constraints? So the first design constraint is the supported wall thickness. If we want to make a wall of such kind of design, then for FDM the minimum wall thickness should be 0.8 mm. For SLA the minimum wall thickness should be 0.5 mm, and for SLS technique the minimum wall thickness should be 0.7 mm. So if we have any unsupported wall thickness, like we don't have any support from both the side, only a wall has been constructed, then for FDM again it is 0.8 mm. For SLS it should be 1 mm. For SLA it should be 1 mm, and for SLS none of the wall can be created. Like since the particle size is so too small, so like making a single layer itself is a difficult task while making it SLA walls. Then if you talk about the overhang or the supporting structure, for FDM, the supporting angle is 45 degrees. So whatever the object which is below 45 degree is going to need a support. If the angle is 45 degree, then no need, then either the support has been needed or not needed. It depends on the user if they want to give the support or not. And if the angle is above 45 degree, then the previous layer itself will act as a supporting layer. So no need to add support if the overhanging feature is above 45 degree. Add support only if the overhanging feature is below 45 degree. Again, it depends on the user as well. Many times when we do 3D printing for the better quality of 3D printing, sometimes we do add manual support even if the overhanging feature is more than 45 degree, just to ensure that the supporting part or the overhanging part doesn't fall off while doing the 3D printing. So that again depends on the user as well. But the criteria for the support is 45-degree for FDM. So whatever is below 45-degree should always be supported, and whatever is above 45-degree are always a self-supporting kind of structure. If we talk about the SLA and SLAs, SLA also, like in SLA, we do need support. Sometimes we need support, sometimes we don't need support. So many times, like the unsintered material itself act as a support material there. That's why we don't need support for the SLS techniques. Then coming with the holes, so the minimum hole which can be printed by FDM is 2 mm, and the minimum hole which can be printed by SLA is 0.5 mm, and for SLS is 1.5 mm. So whenever you are designing, if you want any pinholes to be created within the design, so if you're planning to print it with the FDM kind of technique, so always make sure that the diameter is more than 2 mm. If it is less than 2 mm, then there are chances that it won't get printed properly and accurately. And if we talk about the clearance for the moving part, like when we are making any assembly kind of part, suppose if we have a assembly of cylinder and piston kind of arrangement, and if you want to print the entire assembly as a single part, so there the clearance between the two mating part for FDM should be 0.5 mm. For SLA, again it has to be 0.5 mm, and for SLS it has to be 0.3 mm. So always make sure that you provide such kind of clearance and tolerances while making the assembly. If you're printing the entire object as a single part. Then if we talk about the minimum feature, so the minimum or the tiniest feature which can be printed with a sufficient strength with FDM is 2 mm, with SL is 0.2 mm, and with SLS is 0.8 mm. So these are the design constraints. And if we talk about the pin diameter, so the minimum pin diameter which can be printed is 3 mm for FDM, 0.5 mm for SLA, and 0.8 mm for SLS. And again, the tolerances like this tolerances like the previous clearances what we discussed was about the clearances for the mating part if the entire object has been printed as a single component. And this tolerance is nothing but if you're printing the entire part as a different component, and later on we are going to do the assembly, then we need to have such kind of tolerances. So in that case, the tolerance should be 0.5 mm for FDM, SLA it should be 0.15 mm, and for SLS it has to be 0.3 mm. So these are the design consideration for the 3D printing. So whenever you're doing any kind of design for 3D printing, you should always make sure that you know this parameter, you consider all this parameter while making your successful design. If you avoid any of the parameter, then the thing what will happen, there are more and more chances that your part is going to fail while doing the 3D printing. So coming towards the material, then we have a various kind of material which are available for the 3D printing. FDM, that we have PLA, which is a supporting which act as a supporting material. It dissolves in water and biodegradable. So PVA is a supporting material. Then we have a metal fill material, carbon fiber filled material, conductive filaments, wax kind of material. The wax is nothing but a wax filled material. Then sandstone filled material, glow in the dark material, magnetic field material, color changing material, and TPE. So these are some of the filament which are available for 3D printing. And on the slide, the strength, flexibility, durability, and the printing skill has been also discussed. Like if you talk about the PVA, PVA is one of the material which is quite easy to print. So even the beginner can print with the material. But if you talk about the metal fill material or the magnetic kind of material, so these are the exotic kind of material for the 3D printing, and one needs to have a very good expertise on 3D printing process parameter to get a perfect kind of print out of this kind of exotic material. Then again, we have a PLA, ABS, nylon, flexible TPE, wood field, and HIPS. HIPS is also one of the dissolvable material which act as a supporting structure for the 3D printer. So again, the PLA, ABS are one of the two material which are most commonly been used in the 3D printing, and the printing skill required to print this material is quite moderate, easy to moderate. So even any beginner can print by using this material. But if we talk about a nylon and flexible material, we need to have a very good process parameter knowledge to get a perfect kind of print. So these are all about a polymeric material what have been offered. Then coming towards the process parameter which are been needed for the printing. So we have a printer size, then layer thickness. Uh, uh, like if we change the layer thickness, we can control the quality of the part. Here we can see like on the center is the rabbit, the actual CAD file. So this is the first layer thickness, which has a which has a highest layer thickness, then medium layer thickness, and this is adaptive layer thickness, on which the bottom part has been printed with the rough layer thickness, and the above top part has been printed with a fine layer thickness, and this one is a fine layer thickness. So if we have a thick layer, then the print will be printed very fastly, then the print time will be quite low, quite less. If we're printing it with a thin layer, then we are going to get a high resolution part, and the print time is going to be very high. And if we are doing it with the adaptive kind of slicing, in adaptive slicing, what we can do is like whatsoever is the area or the region where we don't need a very good surface quality, those part we can print it with a thick layer, and the area where we need a very fine surface quality, surface finish, that part can be printed with a thin layer. So likewise, we can optimize the total print time of the object which needs to be printed. Then we have a printing speed. So on the image, we can see the effect of different print speed on the body. Like if the same object has been printed with 10 per second, we are getting a very good quality of print. But if the same part is been printed at 120 per second, then we are getting a very rough kind of 3D print. So even 3D print also.
हाँ बनेगा हाँ
So yeah, even 3D printer also the print speed also plays an important role with the quality of the part which has been printed. Then we have a travel speed. Travel speed is responsible for oozing or threading. Like many times we can see such kind of threads appear on the printed part. So this thread appear due to the travel speeding problem. If we have a excessive kind of travel speed, then such kind of problem is going to arise there. Then bed temperature is there. If we don't provide a sufficient kind of bed temperature, then the part is going to warp a lot. And always make sure that your bed temperature is close to the glass transient temperature of the material which has been printed. Like if we talk about the ABS material, the glass transient temperature of ABS material is around 95 to 105 degrees Celsius. So the bed temperature, what we usually use while printing the ABS material is 90 to 110 degrees Celsius. So whatsoever the value which is closer to the glass transient temperature, we should always use that value as a bed temperature. Then we have Then we have infill density. So again, we can print it with different kind of infill densities. So different infill density will reduce the time, the print time. Like the first image is the part with 50% infill density. So this one, if we print it with this setting, maybe the print time is going to be half of the actual print size. If you're printing it with 100% infill density, so with 50%, it will approximately half the print time. This is printed with 70% of the infill density, and this has been printed with 90% of the infill density. As the infill density increases, the print time is going to increase a lot. Okay. Then we have a different kind of infill patterns. So again, different infill pattern provides a different kind of structure, a different kind of strength to the 3D printed part. Then we have the first layer speed. The first layer speed is one of the most important parameter when doing the FDM 3D printing. If you are not using the optimized kind of value for the first layer speed, then your part is not going to stick to the bed properly. The bed adhesion is not going to be there. Is not going to be there. And the part after printing few layer, the part might delaminate it from the bed, and it will get off from the part. So again, that will also cause a failure for the 3D printing. Then we have a feed rate. The feed rate is nothing but the rate at which the filament is been feeded into the extruder system. So we also need to optimize, like there are two kind of major speed. One is the printing speed, the speed at which the material will come out from the nozzle, and this is the feed rate. Feed rate is nothing but the speed at which the filament will enter into the nozzle. So we need to optimize these two speed, the input speed which is coming into the nozzle and the output speed which is going out of the nozzle. So if we don't optimize these two speed, then again we can see a failure in the 3D printed part as we see in the image. Then flow rate is there, cooling fan is there. So these are the 3D printed process parameter, which there are many other process parameter in the FDM 3D printing, but I have listed out a few of the most essential and important process parameter, which we always needs to enter or take care while doing the 3D printing. So these are the parameter what we discussed. So now let's move towards the software. So I'll try to show you this process parameter in the software and how we can fit the values in the software. So to process the software what we're using is the Cura software to make the slice. So the first parameter is to set up the printer. So to set up the printer, I'll click on the setting. So this is the main toolbar where all the settings are there. So in the main toolbar, I'll click on the setting, I'll click on the printer, and I'll click on the manage printer. In the manage printer, I need to add the printer. So once I click the add printer, then I click on the non-network printer. In the non-network printer, here we can see all the 3D printer manufacturer, the name of the 3D printer manufacturers are there. So among these, we just need to choose a correct kind of 3D printer manufacturer what we're using. So suppose I'm using the Creality and enter 3D printer. So what I'll do, I'll search for the Creality first. So I got the Creality from the Creality. Now, once we open the company, it will show all the models which are available for the Cura software for the configuration. So among all the model, I'm using the Ender 3. So now I have clicked on the Ender 3 and I click on the add button. So once I click on the add button, now you can see the configuration have changed. Now we got the Creality 3D printer. So this is the overall print volume which has been available for the 3D printer. So now printer setup is done. Now the next thing is we need to add the parameter one by one. So the first parameter is layer thickness, second is print speed and travel speed. So I'll put these three values here. So this is the layer height, or which is also been known as a layer thickness. So different software have the parameter have a different names for the parameter. Few call it as a layer height, few call it as a layer thickness, few software call it as a layer thickness. So we just need to depending on the software what you're using, we just need to identify the exact name of the parameter. So in the Cura, it has been mentioned as a layer height. So I'll be printing, I'll put the incoming as a layer height. So suppose I want to print the model with a layer height of 0.3 mm. So I have inserted the layer height as 0.3 mm. Then second parameter is print speed and travel speed. So I'll search the speed here. So this is the speed. I have opened the speed tab. In the speed tab, we can see the print speed. I'm printing it with, suppose I'm printing it with PLA material. For PLA material, the optimum print speed is 60 mm per second. So I've inserted the print speed at 60 mm per second. And you can see this value, the wall speed, the infill speed, the outer wall speed. These values have been changed automatically. So these are all the derived value which have been derived based on the print speed. If I change the print speed, again all the values will change. So these are the dependable value on the print speed. So the ratio are already been there within the software in the algorithm. So if we change one value, the depending value will automatically get changed. Then we need to change the travel speed. So to avoid oozing and to get the best quality of part while printing the PLA material, the travel speed should be around 70 to 80 mm per second. So I'm using, say, let's say 70 mm per second, the travel speed. So now we have inserted the first this three parameter. Then we have a bed temperature, infill density, and infill pattern. So now I'll search for the bed temperature, which I can find it in the material. So here the print temperature, the extruder temperature is also known as a print temperature. So since we are printing it with PLA material, so the optimum temperature for PLA material, it depends on the grade of a material what we are printing. It depends on, sorry, It depends on what kind of grade of PLA what we are printing. So the print temperature for the PLA varies from 190 degree to 220 degree, depending on the grade. So let's say we are printing it with a higher grade of PLA material. So the for which the print temperature is 210 degree. So I'm putting a print temperature at 210 degree. Then we need to set the bed temperature, which is known as a build plate temperature in the Cura. So this build plate temperature, I'll set it as 55 degree for PLA. Then we have infill density, infill pattern. So I'll open the infill tab here. In the infill tab here, we can see the infill density has been mentioned. Suppose I want to print it with 50% infill density. And from this tab, from this down arrow, we can select the type of infill pattern what we want. Suppose if I want to print it with the cubic kind of, let's say I'm printing it with the grid. So I've used the infill pattern as a grid as of now. Okay. Then we have first layer speed, feed rate, and flow rate. So again, coming up with the speed, here we see the initial layer print speed, which has been mentioned as 20 mm per second. So we need to change the speed. So this 20 mm per second is optimum speed for printing a PLA part. So I would change this value. Then we have a feed rate and flow rate. The feed rate and flow rate are, sorry, comes under the material tab. So here we can see the flow rate has been mentioned as the 100%. So, and feed rate is also is derived from the flow rate value itself. So again, here we set the value as 100%. So whatever the amount which has been feeded into the nozzle, the same amount has to be come out of the nozzle. Sometimes we can optimize this value depending on the nozzle depending upon the filament diameter. Like it will help you out when you're doing your experiments. Suppose if you are the filament diameter what we're using here is 1.75 mm. So suppose if you make your own custom filament and unfortunately you're not able to get the exact 1.75 mm filament diameter, and whatever the filament diameter what you're manufacturing through experimental setup is coming around 1.9 mm or 2 mm. So in that case, what is happening? You are putting excessive amount of material within the system, and the nozzle is not extruding the same amount of system. Your system is calibrated as let's say X amount will enter into the nozzle and the same X amount will enter into the will come out of the nozzle. Now, what is happening since the filament diameter has been increased by 0.3 mm? So the value which you are inputting within the extruder system is X plus 0.3 mm. That excessive volume you are inputting within the system, but you are not taking out the same amount of material out of the nozzle. So in that case, if we optimize the flow rate value, if we could reduce the flow rate value, then we can get a very good quality of print, or the chances of nozzle clogging is going to be there, or maybe over extrusion is going to be there. So in such scenario, we optimize the flow rate, the value of the flow rate, or else if the system is okay, if the filament diameter is okay, everything is okay, then we always maintain the flow rate as 100%. Yeah. So these are all the parameters which we usually change within the system. So now we have inputted all the parameters. Now the next thing is I'll import one STL here and I'll try to generate a G code for the same. So suppose this is the STL what we are planning to print. So I have imported STL and I'm going to print it with the uh, PLA kind of filament. So the first thing is whenever we import STL into the system, so we just need to place the part on the platform where exactly we want to print, and we need to choose a proper kind of build orientation. Okay, so like this is the part what we have chosen. So I'll quickly click on the part I'll click on the part, I'll click on this first tab, which is the movement tab. So I'm moving the part on the bed where I need to place the part on the exactly on the bed. Suppose if I want to print the part exactly on the center of the bed, so I'll put this value 0, 0, and 0. Now I got my part exactly on the center of the bed. From here, I can from the second tab, I can rescale the model if I want to print the model of the same size, whatever is been imported. So I can do that, or if I want to rescale it, so I can do the rescaling from here. Like suppose if I want to print it with 50% of the size, what I got, so I can rescale it from here. I have to just undo the model and bring it to the original size. So this tab is used for rescaling. Then the third button can be used for rotating the part to choose the proper kind of build orientation. So from here I can rotate the part and choose the optimum value. Suppose if I print it in this orientation, what will happen? Again, the red spots, what you are seeing here is the spots where support is going to be needed to print the part. So these are all the overhanging part. Okay, and these overhangs will definitely going to need the supports. So if I change the orientation, maybe some of the overhanging part will move. Suppose if I'm printing with this orientation, so what is happening now? We can see the entire supporting structure have changed. Now we need support only on the bottom of the part, but the inside we don't need any kind of support. If I change the orientation, if I again change the orientation, now if I want to print it like this, that again you can see the support structure have been changed. So I'll be needing support on the nose, on the lips, and on the top of the surface. Okay, so here the support has been needed. So just to have a minimum kind of support and to get a proper surface finish, we always need to choose an optimum kind of orientation for the part. Then we can mirror the part. If I want to mirror the part, this button will use to mirror it. From here I can copy the part, and again here these two things have been used to copy the parts. Okay. So this is how we have set up the model within the printer system. Now I have already assigned the parameters within the slicing software. Now the next thing is I just need to click on the slice button. So once I click on the slice button, it will automatically generate a slice. So now it is showing me it needs approximately 17 hours 58 minutes, that is approximately 18 hours to make the entire model, and it will need 227 grams of material. So it has shown us the time and the material which has been needed. If I click on the preview button, it will show me the slice part. Now here you can see that we don't have any support is not being generated within the model. Why this is happening? Because we have not enabled the support within the slicing parameters. So again, I'll come back to the prepare. I'll click on the support tab, and I'll click on the generate support. And once I clicked on the generate support, I'll again click on the slicing button. So it will again make the slice. So it will again slice the part. Now if I click on the preview, so now we can see the support is been generated. Even on the internal part, the generated support can be seen. If you want to see the inside of the layers, so from this button, so it has total 340 layers, as we can see on the right hand side of the screen. If I drag down, I can see all the different layers which are going to be printed. So we are at layer 236. So this is how the layer 236 is going to be will look like. So these are all the layers which are going to be printed for the part. Now, if I want to change the, let's say I want to change the parameter. So if I change the parameter, the infill density, I don't want to print it with 50%. I want to get it print with, let's say 30%. And again, the infill pattern, I don't want a grid pattern. Now I'm looking for a cubic kind of pattern or the zigzag cubic pattern, let's say. So if I slice the model, again the print time will change. So with the updated setting, it is telling us that it will take approximately 1 day, 10 hours, 4 minutes. It means it will take 34 hours and 4 minutes to print the part. And here we can see the infill density has been changed. The infill pattern has been changed. So again, the same thing like the the printing time. It also depends on the type of a parameter what we're using. Sometimes we say if we reduce the infill if we reduce the infill density, then the time is going to be reduced. But at the same time, we also need to look like what kind of infill pattern we are choosing. Suppose if we choose the same infill grid pattern with 30% infill, then last time we got 18 hours of print time. Again, if we're using the same infill pattern with reduced infill density, then the print time should reduce there. So it is going to be reduced there. Yeah, again, it is taking 1 hour and 1 day, 10 hours. That is the same time what we are expecting, the 34 hours, 15 minutes. So it depends on the parameter. Okay. Just a second. Hmm. If we print it with 15% infill density, so for 50% infill density, it is taking 1 day, 12 hours and 39 minutes, which is coming around 36 hours. And for 30% infill density, it is taking about 34 hours. So if we reduce the infill density, we can save almost all 2 hours from the print. Initially, the 18 hours what the system was showing was without the support. Now we are printing the entire model with the support. So that timing was calculated without the support. It is taking around 18 hours, and with the support it is taking around 36 hours. So it depends on the parameter what you're using. So we are going to get the entire 3D printed timing and the material which has been used. So these are all the parameters which we should consider while making a very good kind of G code to make the 3D printed successful. And once we generate a slice file, we just need to save the slice file into the pen drive or the memory card, whatever we have. And there, once we save the file on the drive, on the pen drive or the memory card, we just need to transfer the G code to the 3D printer, and from there we will start the 3D printing. So these are all about the 3D printing, the actual 3D printing part, like how the design has to be there, what parameter we should consider, and how to input a parameter into the software, and how once we get a G code, how the code has to be transferred to the printer and get the printing start. So till now we discuss about this much. Now I'll walk you through with the problems associated with the 3D printing process parameter. Like what if we don't use a optimized kind of process parameter while making the G code? What will happen in that case? So let's discuss about some of the failures in 3D printing. So the first failure is under extrusion. Many times you see such kind of appearance on the 3D printed model. If you see this on the 3D printed model, it is a clear case of under extrusion. So why under extrusion is happening? Because the printer is not extruding a sufficient amount of material from the nozzle. Like if we need 1 gram of material to print a line, and what will happen if the printer is not ejecting 1 gram of material? What if the printer is ejecting only 0.5 gram of material, or the printer is extruding only 0.5 grams of material? So we are not going to get enough kind of thickness, desired thickness into the printed part. So such case is known as under extrusion. So this usually happens when if your nozzle is blocked, if you see such kind of a problem in the printed part. So this usually happens if your nozzle is blocked, or if your flow rate is not properly been set. What we discuss as a flow rate in the software, we put the flow rate value as 100%. If that flow rate is not properly been inserted there, if the flow rate value is not proper, then also we are going to see the under extrusion. And even if the filament diameter is not proper, like what is happening, like the input filament diameter is 1.75 mm. What if we put the filament diameter of 1.5 mm? So again, the same thing will happen. The material which is inserting into the system is not sufficient. The same is not sufficient for the material which is coming out of the system. So again, the under extrusion is going to happen there. Then the second case is over extrusion. So in the previous case, we have deposited less amount of material on the printed bed. In this case, we are depositing excessive amount of material on the printed bed. So this is mostly happen if the calibration of the printer is not good. Like suppose if we increase the flow rate value. So what is happening? Excessive amount of material is bit inserted into the system, into the nozzle, and the material which is coming out of the nozzle is less. So what excessive amount of material which is there within the extruder system, it will try to come out of the material of the nozzle. So that excessive material which is coming out of the nozzle is known as the over deposition of the 3D printed part, which is also known as a over extrusion. If you see such kind of problem within the system, then the parameter what you should check is always the flow rate. Even if your nozzle is overheated, like if we heat the nozzle excessively, suppose the print temperature for the material is 220 degree, and you have heated your system to 240 degree. Even if in that case the excessive temperature may cause to over extrusion. So if you see such kind of problem, always check point number one, your flow rate. Point number two is your extruding temperature, whether you have overheated the system or not. If you cross check these two values, then you can get rid of this problem. Then sometimes we see holes in the gap of the top layer. If your top layer appears like this, then this is a case of an under extrusion. So this usually happens, like there are many parameters because of which this happens. So the first one is the flow rate. Second is if your infill pattern, infill density, what you are printing is quite low. Even if in that case these things happen, and if you don't have a sufficient number of top layer and the bottom layer. So what exactly are the top layer and bottom layer? So if I'm printing it with 50, let's say 50% infill layer, infill, and I printed this cube. So that cube will be solid from outside but hollow from inside. So the outside layer, which is the solid layer, is known as a top layer and the bottom layer. So we should have a sufficient number of top layer and the bottom layer, so that it should be a watertight of geometry. So if those top layer and bottom layer are not enough, then also we can see such kind of gaps in the on the top side. Then we see the oozing, like many times we see such kind of threads appear on the 3D printed part. If this kind of thread appear in the 3D printed part, then these are mostly due to the excessive travel speed or interaction speed. If you see such kind of thing, then the parameter what you should control is like the retraction speed. The retraction speed is nothing but if when the nozzle when the filament is going inside the system, and we move the nozzle from no print zone. So in that case, the filament has been pulled out of the nozzle so that the over deposition doesn't happen on the printed bed. So this retraction, the pulling back of the filament, the speed has to be controlled. This distance has to be controlled. So this distance is known as a retraction distance, and the speed is known as a retraction speed. So we need to, if you see such kind of problems, we always need to control the retraction distance and retraction speed. Even if the printer temperature is too high, then also oozing is going to be there. So we need to control the print temperature. We need to check the print temperature as well, and always avoid the long movement over the open space. Like suppose this is a long movement into the open space, so try to avoid such kind of distance. So if you control this parameter, then you can get rid of the stringing and the oozing problem. Then we see the overheating of the part, like if we try to print such kind of pyramid structure. So on the top of the thing, on the top of the apex, we see the material is not getting deposited properly, and the entire part is been printed with the same temperature. So why this is happening? Because the top of the part is not getting a sufficient kind of cooling. So if we get this kind of problem, then we should always have a sufficient kind of cooling, like the cooling fan needs to be switched on while printing on the apex kind of thing. And even we need to control the temperature of the part. Even if the temperature of the printer is too high, then also overheating of the plastic will happen. And due to the overheating, we can see such kind of disturbance in the structure is going to be there. And even if we are printing it at a very high speed, then also we cannot get a good kind of a proper kind of structure, a supporting structure there to print the part. So we need to control the print speed. So if you are facing this kind of problem, so the pointers what you should be consider is like the print speed, your cooling fan speed, the cooling fan, whether it is on and off, and your temperatures, the print temperature. We need to choose a optimum kind of print temperature. If you use this optimized setting, if you control the setting, then you can get rid of the problem of the overheating. Then sometimes we see a layer shifting or the misalignment. So this usually happens if your tool head is moving too fast. If the tool head is moving too fast, so what will happen? Since the tool head has been controlled by the timing belt and the pulley, so due to the faster movement, it might happen that the belt might skip or jump one tooth within the system. Even if it jump one tooth within the system, then we can see such kind of shift into the printed part. So this misalignment or the layer shifting can be seen there. Or sometimes even if there is an electrical issue or the mechanical issue, since all the system works on the stepper motor, which needs the pulses to get the controlled. So due to even if the fluctuation in the electrical system and the voltage system, those there is a disturbance in the pulses. If the pulses got disturbed within the stepper motor, then also we can see such kind of layer shifting and the misalignment problem. Then we have a layer separation and the layer splitting issue. If the height of the part is too large, then we see such kind of problem, and we can avoid this problem by increasing the temperature of the prints. Then filament grinding is there. Sometimes you see such kind of filament grinding appears on the filament. This happens if the filament if the nozzle of the system is blocked. If the nozzle is blocked, then what will happen? The motor will try to push the filament inside the extruder, but since the nozzle is blocked, the material will not come out of the system. So what will happen? The filament will get stuck at one particular point, and since the roller or the gear will try to move the filament inward, so such kind of grinding will appear on the printed part. Why this grinding is happening? Because the filament is stuck at a position and the roller is trying to move on the same position again and again. So the roller will move on the same position again and again, and it will grind apart from the filament. So in that case, we can see the grinding of the filament. So if you remove the filament from the extruder system and see such kind of grinding appear on the filament, so always check if your nozzle is blocked or not. If your nozzle is okay, then we need to check the other parameter. So one is if your retraction speed is not optimum, then also we can face this kind of issue. Even if your print temperature is not sufficient, like if you're printing it with a very low temperature, like for example, the ABS needs a printing temperature of 230 degrees Celsius, and if you're printing it with 200 and let's say 200 degrees Celsius, so your system is not sufficiently heated so that the molten part can be extruded from the nozzle. In that case, excessive pressure will be built up onto the extruder assembly, and the material will not come out properly. So again, the filament will stuck in one particular position, and we can see such kind of grinding problem is there. So if you see, so in that case, always increase the print temperature. Always check if your print temperature is okay or not. So the pointer from this slide is, if you see this problem, the first thing you are going to check the nozzle, if the nozzle is clogged or not. If your nozzle is cleaned, then check with the print temperature if you're printing with a sufficient temperature or not. So these are the settings which needs to check to have a proper kind of printing. Then we have a clogged extruder or the clogged nozzle. So this usually happens when we try to push the filament manually into the system. So in that case, the clogging happens, or many times when we frequently change the material. Like suppose if we are frequently changing the material, like I'm printing it with PLA, now the next print is with the ABS. Again the third print is with the nylon material. Then upcoming prints will be with the HIPS material. So we are frequently changing the material. In this case, uh, uh, there are chances that the material might get deposited within the nozzle assembly, and the nozzle will get clogged. So if the nozzle is getting clogged, we just need to remove the nozzle and get the nozzle cleaned, and then we can reuse the nozzle again. Then we can see, sometimes we see the curling on the surfaces. So this usually happens if the system is overheated, like if we are overheating the system, then we see such kind of problem. So to get rid of this problem, one thing is we need to control the print temperature, and second thing is, even if we have a very good controlled print temperature and still facing the same issue, then we need to optimize the cooling fan speed or the turbo fan speed. So once we optimize the turbo fan speed, then we can get rid of this kind of problems. Then sometimes we see such kind of scars on the top of the surface. So this is happening if we are over extruding the material onto the nozzle. So these are nothing but the nozzle marks onto the top of the surface. Sometimes we see this kind of gaps appear on the 3D printed part. So this gap usually appears if the design is not proper. So what is happening if you are printing it with a 0.4 mm of nozzle? So whatever the line width what we are going to draw there, it is going to be the multiple of 0.4 mm. We cannot print 0.1 mm line with 0.4 mm nozzle diameter. So it always the width of the line which has been printed is always the multiplier of the nozzle diameter. So suppose if I have a nozzle diameter of 0.4 mm and I want to print a wall which has a minimum wall thickness of 0.6 mm. So what will happen? So it will print the first layer as 0.4 mm, then it won't print a gap of 0.2 mm because that gap is not a multiplier of 0.4. It has if it was a 0.8 mm, then it might have printed the second line. So in such cases, we see this kind of gap appear into the 3D printing system. So if you see such kind of gap, always make sure that your design is the multiplier of the nozzle diameter. Like if I increase the width of the design, sorry, if I increase the width of the design here as 0.8 mm, then I won't see such kind of gaps appear onto the 3D printed part. So again, the next thing is very small features which have been printed. So this we have already discussed in the design consideration. The minimum wall thickness which needs to be printed with the FDM is 0.8 mm, and it also have to be the multiplier of the nozzle diameter. So still, like we have a nozzle diameter of 0.4 mm. So the minimum feature which has been printed there, or the minimum line which can be printed there is 0.4 mm. So whatever the lines or the feature which are there, which is less than 0.4 mm, will not get printed. because those value will not get converted into a slicing software since they are not a multiplier of the nozzle diameter. Sometimes we see inconsistent extrusion. If you see such kind of problem, then there are chances that your filament might get entangled. Your filament is not free to move into the extruder system. Even if your nozzle is clogged, then also we see such kind of problem. If we have a very low layer height, then also we see such kind of problem. If the extrusion width is not proper, then also we can face such kind of problem. Even if the filament quality is not good, then also we can see such kind of problem. And sometimes if your extruder assembly, the gears in the extruder assembly are clogged, are jammed, material has been stuck into the gears, then also see such kind of problem. So if you're facing this, so we need to clean the extruder, we need to clean the nozzle, we need to have a very good quality of filament, and we need to make sure that the filament is free to move within the system. If you have all these criteria fulfilled, then only you're going to get a very good quality of prints. Then there is another problem with the warpage. So sometimes we see the warpage are there. So warpage usually happens if you're not printing the part with a heated bed. So always make sure that your heated bed has a temperature close to the glass transient temperature of the printed part. And if you don't maintain that temperature, then warpage issues are going to be there. So these are all the parameters, the problems which are associated with the parameter. So which we should consider while getting a very good quality of part. So if you face any of the problem while doing a 3D printing, now you know the process parameter. Now you know which parameter has to be controlled to get a very good quality of print. So these are all the practicality or the practical problems which are associated with the design. So to get a good quality of print, we have to consider three basic things. The first one is the design consideration, the minimum features which needs to be printed, the minimum criteria tolerances which needs to be considered while making the part, while making the design of the part. Second thing is the parameter, what we are using while generating the G code. So we need to use the optimum kind of parameter. If we are not using the optimum kind of parameter, then we can see the problem what I have tried to discuss, show it to you. Then such kind of problem can be seen onto the printed part. So these are the two things which needs to be considered to get a very good quality of the part. And the third thing is the calibration of the 3D printer. If your 3D printer is calibrated properly, if your bed is properly bed level, if your assembly, if your the guide rods, the X rod, Y rods are properly been aligned and calibrated, then only we can see a very good quality of part. Even if you make a very good kind of design with all the design consideration, if you have used all the optimum 3D printing parameter to get a very good quality of print, still you're not getting a good quality of 3D printed part, then you need to check the calibration of the 3D printer, whether your bed is properly aligned or not, and your system is properly calibrated or not. So these are the three considerations which we need to check to get a very good quality of part. Now, so that's all from my side. If you have anything, if you want to know anything about the talk, what we have discussed, so I'm here. I'm here to solve the queries for you. Yeah, thank you so much for the opportunity.
Okay, thank you, Piyush, for this wonderful interaction and another wonderful session. What I feel that you have covered very beginning with the very fundamentals of 3D printing and just utilization of the various softwares, and the most special that the the failure studies and various aspects you have discussed a lot in depth. So I think these are the very challenges for the aspirant in the domain of additive manufacturing, and I feel that those shortcomings you have responded and how those challenges or failures can be overcome. So definitely they will help it out in our routine research works to our participants. So dear participant, Piyush is now ready for queries if any. So you can similarly as daily practice, you can write in chat box, you can directly interact with Piyush, because we are having few 10-15 minutes here, because Professor A.M. Kutesa will start his session by 11:25, 20 by 30 maybe. So we are having some time here. Just interact with Piyush and just let some query to be discussed here. So definitely those queries are some of time very common to all. So that if one is asking, so definitely simultaneously it is just solving the very difficulties to everyone. So Piyush, we are just waiting for some queries so
Yes,
that
sir.
we can.
Sure. Because what happens now, this many people don't discuss about the troubleshoot or the problems which are associated with the 3D printed parts. So that's why I try to discuss this
Yeah,
practical
that's
approach, this practical problems.
that
Yeah.
really make this discussion and entire this session more interesting, even more fruitful, more meaningful, because participants are just be here huge we have received from our participants in this particular domain. And obviously when we conduct some research and development work, lot of challenges are there and they are need to be overcome. So yes, please. uh, Someone has written something, but I'm unable. Most of the issues are covered and given a good information how to overcome clearly
So
under. Yeah. Does super finishing operations needed after 3D printing?
yeah,
Super
we
finishing.
do need super finishing operation. So these are known as a post-processing operation. So we usually do it to make the part more finished to give the part more finished kind of look. So we need super finishing operation. And what Nevat is saying, that most of the issues have been covered and given a very good information how to overcome. Reality Ender has more issues, but the thing is, like, Reality Ender is an open source software. It's an open source DIY kind of printer. So the issues what you're telling about the printer is, like, many times you can see if the same printer has been used by me or anyone else, then the quality of the part is going to be very good. If the same printer has been used by the beginner, then the quality of the part can hamper. So it depends on how well you have calibrated the 3D printer is. And apart from, since Reality Ender is a DIY, so we need to assemble the printer by ourselves. So when we are doing the assembly, we need to ensure the calibrations there. And many times, like, we have a sophisticated systems, like let's talk about FlashForce Creator Pro. So which is a pre-assembled kind of a 3D printer which comes into the market. So if you're using such kind of pre-assembled printer, so those printers are properly being calibrated by an experts. So in that case, you will get a very good finished, you will get a very good quality of the part which have been printed from the printer. So rather than blaming or rather than saying that one printer doesn't give a very good quality, we should always consider the points which are there which hampers the quality of the printed part.
Good morning, sir.
Yeah,
Am I audible, sir?
yeah, you are audible.
Sir, I have one query that if I want to make a composite printing, that if I want to
Mhm.
uh, do two kind of filaments and simultaneously, so in this FDM process, so how should I proceed? Should I make the filament composite, or there are some techniques that I will feed to polymers and it will print one product, means composite product?
Sorry. So you need to make the filament, like if you're going with the FDM kind of 3D printer, the basic input what we use in the FDM 3D printer is the wire, the filament. So the prerequisite, you should have a composite filament ready with you. Then only you can print the part with the FDM technique. Or else Dr. Narendra might have discussed in the session about the palette 3D printing, what he usually does. So his expertise in the palette 3D printing. So if we are using the palette kind of 3D printing system, then there are chances that you can add the palettes, the polymer palettes and the additives what you want to print. You can add all those things into the barrel, and the barrel in the barrel the screw will move downward, and it will force the material from the nozzle to extrude, and there itself you can have a composite kind of material getting printed. So if you're using that kind of system, then maybe you can add the additives within the printer itself. But if you're using the FDM kind of 3D printing system, then definitely you need to have a composite filament to be made first.
Okay, sir. Thank you, sir.
Yeah. And Shiv Prasad is asking about the chemical bonding between the layer and the strength variation, also consistency of the layer. So Shiv, it depends on the again, it depends on the parameter of the material. Like if you're not using very good kind of printing temperatures, then also it can depend. So like the layer bonding also can be delaminated there. Suppose if this is the point where we are printing, so I started from this particular point, and this is the heated this particular point when we have just extruded the material is quite heated. Now my nozzle is moving from this point, moving up and coming back to the same position. So when it is reaching back to the same origin on the next layer, if in that case if the beneath layer is being cooled, so what will happen if the layer is cooled enough, then there are chances that the binding between the two layer is going to be very weak. So there again, delamination can happen. So in that case, we usually try to maintain the chamber temperature as well. So we use the closed kind of system, the closed kind of printer, where the inside environmental temperature can be maintained up to a degree of can be maintained, and even the temperature has to be maintained like somewhat close to the glass transient temperature. So if we maintain that environment, that heated environment, then there are chances that the chemical bonding between the layer is going to be very good, and layer delamination will not happen quite frequently as what is it is happening with the open kind of 3D printers. And then we can have a very good strength within the layers. And Georgeline, we cannot overcome the anisotropic properties within the 3D printed part. That's one of the biggest challenge in the 3D printing right now. 3D printing always have a directional kind of property.
Piyush, I think one last query was there. Someone was
Yes.
asking about how to avoid or how to overcome
Over
anisotropy. Yeah.
I just answered that, sir. 3D printing,
Okay.
in 3D printing, we have the directional property. So that's
Okay.
one of the biggest drawback and the challenge for the 3D printing. So like if we are printing it with 0 degrees Celsius, like this is how the part layers have been printed. If I pull the model from this side, then there are chances that the layer delamination is going to happen. But if this is the direction of the printed part, if I pull the model from this side, then then the part will have a very good strength. So this directional problem is always going to be there in the 3D printed part, since we are printing it with the nozzle, and the nozzle is extruding the material in a directional way. So that problem is always going to be there associated with the FDM kind of technique. And but if you're using binder jetting technique, then somewhat you can reduce the problem for the directional properties. But with FDM, this problem is always going to be there.
Okay. Okay. Okay, Piyush, I think some more queries, one or two queries are there. So on YouTube also some are asking, so that I will just read it for you.
Properties. But with FDM, this problem is always going to be there.
Yeah, Piyush.
Yes, sir.
Yeah. On YouTube live also we are doing now. So someone is
Yes, sir.
asking,
Yeah.
Deepali, asking about, she's
Mhm.
asking that, sir, please tell me the name of the software you have shown in demo.
I have showed the Cura software in the demo.
Okay. Okay. So I think Deepali will note it down that Cura software was used. Have thought of have thought of working 3D machine to manufacture herbo mineral products. Herbo
Mineral
minimal
products.
mineral products. Yeah, one of the viewer Srikanth is asking. Have thought of 3D printing machine to. I think he's asking about some application area. Means that whether under the capability of 3D machine to manufacture herbo mineral products?
I'm actually not aware of what exactly is Hubble mineral product. So
Yeah.
I
I
have
think
to
it
check
herbo
with that.
mineral. It may be somehow maybe
Her,
some medical area, some medicine kind of. It is related because
herbal.
we also
Okay,
yeah
he might be herbal mineral products.
something
Got it.
related.
Yeah. So herbal mineral products, like we cannot use it with the FDM kind of 3D printer, because in that case we need to have that herbal mineral as an input raw material. So whatever, if we can have that material as an input raw material, then we can definitely print the herbal mineral products, as we do it with the drug 3D printing. In the last session, we have discussed about the drug 3D printing, where the input of the material itself is a kind of a drug which needs to be printed. So again, here, if the input material is in the kind of a herbal mineral product, then definitely we can use that input raw material to get the printed part.
Another is Durgesh is asking about, is FDM printed scaffold permeable for implants? FDM, I don't think so. That means of FDM
FDM
printed
printed
scaffold.
are not FDM printed
Uh,
scaffolds are permeable for implant. It depends on the raw material. Like FDM printing, we used for the peak material. So the peak is a biocompatible material which we can use it to make the scaffold. So if you have a material which is biocompatible, which can be used as an implantable material, and that material has a capability to get it printed with the FDM kind of system, then only we can print the part. One thing always keep in mind is that FDM is nothing but printing a thermoplastic. So whatever the material what you have to get it printed, so we always need to check the extrusion temperature, or the temperature at which the material will change its shape. So if that temperature, if your system allows to reach that temperature, then only you can use that material for FDM 3D printing. Like for example, if you're printing with the peak material, peak has a printing temperature of above 400 degrees Celsius. And if you want, you cannot use the peak material with the existing kind of FDM system what you have, like the Creality or Creality or Flash Print or Ultimaker, whatever the basic printers what we have, we cannot use those printers to print a peak, since this printer has a highest temperature of 280 degrees Celsius. So if your system allows to reach up to 500 degrees Celsius, then only you can use the peak material to get it printed. So FDM printers are there which prints the peak material, but those are the specially made printer which has a highest extrusion temperature of 500 to 600 degrees Celsius. So always check if the material, what is the extruding temperature for the material what you want to print. The first thing is it always has to be a thermoplastic. Second thing is you should check the temperature, the extruding temperature. And third thing is you should check if your system is allowing you to reach that much of temperature or not. If these three things are these three criteria are been fulfilled, then you can print the part with the FDM systems.
okay, Piyush, one last query, then we will compile.
Yes, sure.
From where we can buy this Creality and printer? Any vendor in India?
There are many vendors who supply the 3D printers. You can Google it, or even you can find the 3D printer on the Amazon marketplace as well. Amazon and
Yeah.
Flipkart also supplies the material. So you just need to Google it and you can find the vendors there. Since in this platform, I am not allowed to tell you about the vendors. It's academic kind of thing. So I'll try to avoid discussing about the name of a vendor who can supply you the material. But you can Google it and you can find it out.
Okay, Piyush, lots of queries, lot of interaction, problem solving session it was. And, I am just delighted to have you here, and both of the sessions of yours was amazing, and our participants have asked a lot of queries, and your fruitful the solution you have provided, really they are just going to help them out in their routine research and development work. So thank you for Piyush, for your valuable time and being here. I know that
Thank
still
you
you are
so much,
not
sir.
in India and you are in Dubai this time. I can feel. Yeah, so still you are just taking time out of your busy schedule, other assignments also. So I'm thankful to you, grateful. Thanks a lot, Piyush. See you.
Thank you
Okay.
so much, sir. Thank you. With your permission, I'll take a leave, sir.
Please.
Sir, I request you to please share the slides to all of us. It was very nice slide,
Sure, sir.
smooth session.
I'll do that, sir.
Yeah.
I'll share it
But-
with Ravi, sir. So if you could just
Because
circulate
till
it
now
with
we
the
haven't got any
participants.
slides, sir. That's why.
So dear participants, we are just compiling here. Wonderfully delivered his session, and it is now 11, 16, 17. So by 11:30, Professor A.M. Kotesar from BNIT Nagpur, he just going to join us very soon. Okay, so as per the schedule, it will be held, and that will be our session 2 for today. And as we have already informed you all that there is no post-lunch session, because both the sessions have been already covered in pre-lunch time. Okay, so be there and please be here, or even if you feel, then you can take a break of 5 or 10 minutes, whatever, and please be here by 11:25 or 30 at least. Thank you so much.
Thank you, sir. Thank you.